Welcome back. This is MLOps Zoomcamp, and in this module we are talking about best engineering practices. And in the previous video we talked about unit tests and we refactored our code a little bit. As an example, we used the streaming code from the deployment module. So we took the code for an AWS Lambda function and we refactored it a little bit to make it easier to test, and then we covered the code with tests. So now our Lambda function looks like that. It delegates everything to this model service, and then the actual code lives in this model.py file. And yeah, we have classes here, and now things are easier to test. This is our test, or tests. I think we have 4 of them. Right. And these tests, the scope of this test is quite limited. So they test only a function, right? So they don't test the entire thing, that the entire thing still works, it doesn't fall apart, and it can receive a request and it can get a response. Right. And for that, what we've been doing so far, we had this test underscore Docker.pi. And so this was kind of a test that shows us that this thing still works. So we can send it a request, and then we can get some response. So to actually use this, we run it in Docker. So we run our service in Docker, and then we send a request, and we get a response, and we just print it. So now we can actually take this and turn this into a test. So let me open Visual Studio Code for that. And let us just first run this test to make sure this thing works. Yeah, I think this is what we use for this. I'll probably first rebuild it to make sure that the latest code is used. And then I will run it. Okay, and then from a different window, from a different terminal, I will just run test Docker. And hopefully it still works and replies with something. I don't know why it takes a bit of time. Yeah, I think it's slowed in the model. So yeah, luckily it's still working. Well, we didn't test, because it's test run, we didn't test the Kinesis part. Let's not worry about this right now. We will talk about this a bit later. For now, we can see that this thing works. Actually, it can handle our request. It can decode it, and it can apply the model. It can also download the model in the first place from S3, because I think here we actually specify the run ID. Yeah, it goes to S3, fetches the model, and runs it. We have this kind of test. It's not really a test in the sense that we are not testing anything. We just see the output. So we run it and we see that there is some output, and we just assume it works. What we can do though is we can take this test Docker.py and turn this into a proper test. Turning it into a proper test is not as difficult as it sounds. All we need to do is just add a few asserts. So first, we'll follow the same kind of naming convention as we did for unit tests. So we have actual prediction and expected prediction. By the way, I think I forgot to add an assert here. Nah, that's funny. I hope it still actually works. Okay, let me quickly check that this thing works. I will execute all the tests. Yeah, it works. So yeah, we need to have this assert to make sure that the result we get is the result we expect. And actually this assert is a built-in thing in Python, so we don't need PyTest for that. PyTest is just a convenient thing for running tests like this. So we have multiple tests, and then we can run them, all of them, or individually. We can get nice reports. But in principle, we can just add asserts in our code, and if the condition that we have here is not true, then it will exit the script with an error. So what we can do now is we can just get the response here. So I will do something like actual response. So I'll get JSON from here, and then expected response, and it will be, let me just copy this. So we have prediction, and then we have model, version, and wondering why version is none. So something is wrong here, because it shouldn't be none. It should actually be something else. Yeah, I don't know. I think it should be, the version should be run ID, this one. So you see, we actually can spot an error now. So this is the expected response, and we have actual response, and we can do actual response, expected response, and then see that they match. Right, and then I can just go and executed, and we get this assertion error. It would be nice if this thing actually prints the actual response. So I'll do something like actual response, and then I can print it. JSON, let me import JSON. Now I want to import JSON because then the dictionary with the response will look nicer. So I'll just do dump s actual response, and then I'll add formatting here. So it will look nicer when I print it. So this is the response, right? And we see that the version is null, but it should be something else. Yeah, this thing is actually not very informative. So we want the test to tell us what is actually wrong, on which field the assertion doesn't work. And for that, there is actually a nice library. It's called DeepDiff. So let me just Google it quickly. DeepDiff. So this is a library for, let me open it on GitHub. So this is a library for what we need to do actually for comparing dictionaries. So yeah, I'm just looking for a good example, but basically, yeah, it tells us, if given two dictionaries, it tells us where in which part of the dictionary it's actually different. So let me install it. So I will do pip env install. So it is a development dependency as well. DeepDiff. Let me start from importing it. So from DeepDiff import DeepDiff, and then I will do something like diff equals. Then it compares this T1, T2, which in our case will be actual response and expected response. And so now I will not print any asserts. I don't remember how exactly on which we should assert it, on which fields. So I will just now want to see how it looks like, how the result looks like, and then we will modify the code. Okay, yeah, I need to do pip env run. Yeah, now we see that type change. This is not what I thought we would see. Actually, it says old value is known, new value is this one. Although it should be like actual value, expected value, but doesn't matter. The thing is that we see that there is type changes. We are printing this diff object. So there are type changes, and it says that the first element of prediction version is different. So we actually want to assert on this one. So it should be empty. It shouldn't exist at all. I think if we don't have any type changes, any differences, then we just get an empty dictionary. So what I want to assert on is that this thing is not in diff. And actually, I want to print it first and then make the assertion. So, and now when I run it, we get assertion error because type changes is in the diff dictionary. Okay, now let's fix it. So I will go now to this model and model version. Yeah, I think we forgot to add this when we initialized it. Model, and actually we also forgot to add a callback. So model version will be run ID, and let me make it multi-line. Have model equals model version run ID, and then callbacks is callbacks. I think I didn't forget anything. So we have model version, and callbacks. And now we initialize the model service with all these things. So now we need to rebuild our Docker image and test it again. I'll go here, stop it, run Docker build. And actually now it needs to install everything again because we added this DeepDiff library. Okay, and let me run it one more time. So it's the same tag v2, and let me run it. Great, so this object is empty, which is good. So this is the difference. Let me make it clear that this is actually a difference. So I'll do something like this, or maybe even this. So far so good. One thing that worries me is this part. So because this is super exact, and we mostly don't care about this part, right? So we care that it's approximately okay when predicting the duration of a trip. We in general don't care about seconds, we mostly care about minutes. So maybe we want our duration to be like this. right? And because of floating point arithmetics in Python and in general, we usually have these long floats, right? And I think when we run this test now, it will complain that, yeah, they don't match. So you see, value changed. In expected response, it's this, but in the actual response, it's this one. And actually, this DeepDiff library, we can also set tolerance to comparing floats. So we can say that we care only about some significant digits in a float, and then it will ignore the rest. So it's, I think, significant digits, and then let's say 1. So I think it means that it will only care about 1 significant digits after the dot. At least this is my interpretation. Now you can see that actually it passes. Although I forgot to modify our assert, so let me remove it for now, because I want to add another assert. So I want to make sure that this value changed does not appear as well. Not in if. And now I will, because now if I run this, I will actually have an assertion error. Right? And this is what I want to have. But now I add this back, and again the test passes. One thing I don't like about this test is it actually needs to go to S3 to fetch this version of a model. It needs to go to S3. It needs to download it from there. So I think for a test, we want to kind of limit the scope. So we don't want to be dependent on S3. What if we run this offline? What if this test actually cannot go to the internet and download the model? Or what if it doesn't have permissions to do this? What if this model is removed and it's no longer there? And here we then don't actually care about the accuracy of this model. We just care about the flow, that the whole flow of getting a request and making predictions actually works. So here we can see how we can remove this dependency on S3. And actually, when we download the model here, like here we specify an S3 location, but it can also be a local file. It doesn't have to be an S3 location. It can be a local location, a location on the local file system as well. So I'm just thinking how to do it best. And also I don't like that I kind of hard-coded here the value of the bucket. We can use this OS. We can use the environment variables to configure this. So for example, I can say model bucket. Yeah, model bucket, and it will read from the default bucket unless we specify it. And then experiment ID will be os get env. It's MLflow experiment ID, which in our case is 1, and then I can put it here. So later, if we change the bucket or we change MLflow experiment ID, it's very easy for us to actually adjust this. But this is not what I wanted to do, because we are still going to S3. I wanted to change this behavior and also have a way to load from a local file system instead of S3. And I think that maybe we can just specify the whole path. So we can give a way to define the whole path, and if it's set, then we use it. If it's not set, then we build the path ourselves. So I'll do something like get model path with run ID, and I will put all these things there, and I'll use locked model get model path. And probably it makes sense to rename it something like model path run ID. I don't really like that we mix here OS and run IDs. Maybe I should make them global variable. I don't know. Okay, let me not spend too much time thinking about this. Yeah, I can just keep them here. It's not important right now. What important is we want to have a way to set the model path, and we can say that model location. Actually, I like this name more than model path. Model location. And if it's set, and if model location is not none, meaning it's set, then we just return it. Otherwise, we do this thing like we did previously. Yeah, and then we can override it here. So then this will get this model path, and then it will load the model from the specified location. And next thing we can do is we can just go to S3 and download this model and use it in our tests. For that, I should create a folder. I'll call it integration test. Integration tests or test. Integration test, and I will move this Docker there. And here in this folder, I will also put the model that we will download from S3. So let me cd to this directory, and I will go to S3, AWS, S3, ls. So what is the bucket name? This is a test. So the bucket name is this one. Then it's one. Run ID, I don't remember. Let me check. I think this is this one. And we have artifacts here. And we have the actual model here. And let me take this thing and download it to local file system. So I'll do cp recursive. And yeah, we'll put this to the model folder. I think I made it recursive. Okay, now we can see that in this model, we have all these files. They shouldn't be too large. So the model is kind of somewhat large, but the rest of the files are quite small. So it's kind of okay to keep this in our Git repo for tests only. And now when we start our Docker container, so I will stop it right now. I will go to README and I will copy this thing. And here this run ID will stay, and I will add another parameter. And this parameter will be model location. Yeah, model location is the path within the container. So we can do something like app model, but also now we need to mount this folder, model folder, to this /app/model. So for this we use the -v flag, and I will use the current directory. So if you use Windows, you need to specify the full path, and then model, and then so this is the location on the host machine, and this will be the location on in the container. Right? So this way we link this directory here with the model to this location in the container, and then in the container we say that the model actually lives here. Go there, download it from there. I don't know if we need a slash here or not, but let's see. And we also need to rebuild it. So I will rebuild it, and I will run it now. And just to check that it works, so let me have something like, let me change the run ID. I'm doing this to make sure that it doesn't go to S3, and also it will change this thing here. So the version will be different. So we will also see how well our test works. So it should actually fail, but it should download the model. It should successfully respond, but the test will fail. Right? So let's see. So okay, it's running, and now I will just run this Python Docker test or test Docker. Yeah, pipenv. Okay, something went wrong. So let's see. Yeah, I'm not sure if I'm doing this. Yeah, I'm doing this. I need to go to this integration test, right, to run it, because it assumes that we are in this location, right? So we are in this folder. So let me run it one more time and run the test. Okay, now the error is different. This is the expected error. So we got test 1, 2, 3 instead of this value. So, and actually, let's keep it. So it will be the version of our model. Okay, so far so good. I actually want to automate everything, because right now to run the tests, I first need to build the latest version, then I need to run this thing, then I need to go to a different terminal window, I need to run the thing, and yeah, actually I think I still need to check it. Right, yeah, now it works. And I need to run this again, right? This is still too manual, and we want to automate this test completely. So we just want to have a simple script that we run. It builds the Docker image, it runs it, and then it runs the test as well. Let's do this. So I'll create a script. I'll call it run sh. And usually we need to start the script with a thing called shebang. I don't know how to actually pronounce this, but I keep forgetting how to, like, what exactly I need to put here. So let me quickly Google it. So I'll just write bash shebang, and I usually just copy this thing. So what this thing means is we need to use the bash command. And so this env looks for a bash command on the path, and then it uses this for executing the script. And it might happen that we run this script like this. Let me do change mode +6. I want to make it executable. Run, right? And we may run this script from here, for example, from this folder, or we may cd here and then do run sh, right? And regardless of this, the script should work. So the first thing I want to do here in this script is to change directory and to go to the directory of the script. So I want to make sure that when this script runs, the current directory of this script is this integration test. And for that, there is some magical command in bash that I always need to Google. And I think it's bash script cd to directory. Then, oh, where is it? Yeah, this is not what I want. Bash script to script directory. Yeah, this one. So I don't know how many times I visited this page. I should upvote it, I guess. Maybe next time. Anyway, so this scripting thing cds to the directory of the script. And now when I do pipenv run test docker, pipenv run python test docker, it will be able to find test docker because we will make sure that it's always running from this directory. Okay, before we run test docker, we actually need to make sure we set everything up. Yeah, so what we were doing before, I think it's in this readme. So we were first building, and then we were running this thing. Okay, so first thing, instead of using the same tag like test all the time, we can have a tag that more depends on a version of the code. So one way of doing this would be using the current git commit, git hash, but then we don't always commit the code to git before running tests, because you see I have a lot of changed things which I didn't commit. So just using git commit hash is not enough to give, let's say, a unique identifier for this tag. But what we can do here is we can get the date, the current execution date, and then use this as the tag. And for that, there is this date command in bash, and we can specify the format using this format afterwards. So for example, this should give us the date, and then we can also add here minute, first hour, and then minute. I think it's like that, yeah. And this is what we can use for tagging our image. So I'll create a variable, I'll call it local tag, and then local image name will be this one, stream duration, and then local tag. So now we build it, local image name, and we also run it. And now instead of using Docker, actually I want to change it to Docker Compose, because in Docker Compose it's easier to keep track of all this configuration. So I'll create a file, Docker Compose YAML, and I do not remember the syntax for this. So let me quickly do Docker Compose YAML, and then there will be an example that I can just copy, this one. We don't need any of this, but yeah, we'll call it backend, I guess. So this will be our service that we test. Yeah, local image name. So the name will be this one. So here we can also specify these parameters like that, and then it will use environment variables for this. And then we need to let me just quickly copy it here. So I remember what I need to do. So I need to open ports. Yeah, I really wish I had Docker autocomplete here. So maybe I quickly find an extension for this, for Docker. Yeah, I need to install it here. So it's installing. Cool. Okay, now it's much better. So now I have auto completion, suggestions. Then what else? Yeah, environment. So we have a bunch of environment variables here. So prediction stream name, we don't need codes here. Test run true, and then AWS default region as well. And we also, I don't see it here, but we actually need to do this mounting. Remember, we mounted the folder, this one, model folder. So we do this using volumes, and then first it's local path, and then it's container path. So the container path will be up model. And yeah, another environmental variable that we forgot. Let me quickly take a look from here. It's model location. Yeah, I don't think I forgot anything. So we have the image, we have the port, we have environmental variables, and we have volumes. So, and now I will first test it. So I will execute this thing. So I'll stop it here. I will execute this. Yeah, actually we need to go one level up. Right, so we built an image using Dockerfile in the code directory. So we need to go one level up. And this is the tag we used for building the image. And now I just need to do docker compose up, and it will start the service. Now local image is not set. Oh, why? Now yeah, I think I need to export it. So I need to export this, run it again. Okay, yeah, now it's the same thing that we were doing previously, but it's just one command. Let me quickly check that it's still working. Yeah, so we forgot to add run ID, which is test123, I think, without quotes. It should be test123. So I will stop it and I will run it one more time. So let me run the test. Cool, it works. And then actually right now when we start it, it kind of takes over the terminal, right? So we cannot type anything here. We can only see whatever Docker Compose outputs. But ideally we want to do it in the same script. But if we just do Docker Compose up here, so this thing will just take over the shell and we will not be able to execute this command. But we can run it in detach mode. So I will stop it right now and I will run it in the detach mode. And it just ran it and gave back the terminal. So I can continue doing what I was doing, which means I can now go to that terminal window and run this thing there. So it works. And now I can do Docker Compose down to stop the service running in Docker Compose. Did it stop? Yeah, I think it did. So this will be our script, Docker Compose down. Usually, like when we run Docker Compose, it's a good idea to give it some time to actually properly start. So we will add sleep 1 second. So it will sleep for 1 second. It will run something here. It will immediately detach, give us back the terminal, and we will execute this thing. But maybe, yeah, we just need to wait a little bit. So we will wait for 1 second before running this thing to make sure that everything is set up here. Now let me run the script. So we built the image. Now we started Docker Compose, then we ran the test, and we did Docker Compose down. And now we can see the error code of this thing. So think it returned as an error code, a 0. So 0 means that the program finished successfully. This thing $? Means give me the error code of the previous command. So it is 0, meaning that it finished successfully. And if we run this, let's say somewhere in CI/CD, which we will cover later, CI/CD will mark everything as good if the error code is 0, and it will mark a job failed if the code is non-zero. So we actually, when we run the script, we want to end the script with a non-zero error code if something is wrong. Let us artificially change our test to fail. So I will change the version here. And now when I run this, it should fail. And ideally, the error code we get from the script should be 0 or non-zero, should be like 1 or something like this. But it's actually 0, right? So it is successfully finished. This is not something we want to have. And the way we address this, one thing we can do here is we can do set plus x or set plus e, I think. Yeah, so this thing says when you see the first non-zero error code, terminate the entire script and exit with non-zero error code as well. So we can check this out as well. So let's see how well it works. So now it should fail and the error code should be non-zero. Something is wrong. Maybe it should be -e. So let me quickly Google this. Bash script interrupt on error. Yeah, it's -e, of course. So let me run it one more time. Yeah, you see what happened? So it's an assertion error, and then the error code was non-zero, 1, and it exited the script with 1. Yeah, this thing is very long, so let me change it quickly. So it's annoying. Yeah, but the thing is that because we exited it, we didn't execute this one, Docker compose down. So that's why this thing does not work for us. But what we can do instead, we can write error code to a variable. So it will be this thing, right? And now we can check if it's non-zero, then we do something. Maybe we can throw the logs, for example. Like I can do something like if error code is non-zero, and then I always forget the syntax, the bash syntax for if statements. I hope it is right. And then, for example, we can show docs here, docker compose logs, before removing everything. And then we exit with the error code, this error code. Okay, let's test this. So this thing fails, then we should be able to see logs from Docker Compose, and we should be able to stop the container. Okay, I think this is what actually happened. So we have an assertion error. Because there was an error, we got to see the logs from the container, and it's actually quite useful because there could be an error there in the container when we execute something, so we want to see the logs from there, and then it executed Docker Compose down. And if we look at the error code, it's 1. So our CI/CD job will fail. It will mark it as a failed job, and then we will go there, we will see the logs, and we will make a decision what to do next. Now let me fix the test. So this test should work fine. Yeah, now we have a working test, and so the way we can execute this is we can do integration tests.run, and then yeah, it will work. Yeah, that's good. I think we covered almost all the things in our service, but we shouldn't forget about one important thing. And this thing is this Kinesis callback. So right now, because we are setting test run to true, we do not actually send anything to Kinesis. And because we changed the code in the previous video, we didn't really cover it with tests. So I am not sure this part is still working. It might not be working because we touched this code, right? And I didn't even try to test it manually. I didn't try to deploy it to Lambda and see if this thing is actually working or not. So ideally we should cover this as well. And this is actually something we will look at in the next video. So in the next video, we will see how we can test AWS services locally, even if you don't have an AWS account. So this thing will work completely locally, and this is very useful when we need to test things like Kinesis or S3 or things like this. So see you soon.